Hi guys, we're just going to give it a minute, wait for other people to show up. And remember today, I'm just working through problems for 1.7 classwork problems, although I can answer problems on homework and other stuff. And I also posted additional practice problems for midterm 1 that should be up online. That got posted last week. I'm going to give it a few more minutes before I start, before I keep working on the classwork. So today and Wednesday, these are just review days. I'm going to finish working on classwork for 1.7. You guys are welcome to work on classwork too, or work on homework and ask me questions as we go. I'll open up my chat window here. Hang on. And then Wednesday, of course, is just a review day. So you guys can come prepared to ask questions on Wednesday. It's kind of to think about it as like an office hours. Okay, and then Thursday we decided that we won't have class on Thursday, so you guys can spend that time getting prepped or doing other things or whatever for the exam. The exam will start on Thursday at noon. Okay, that's when the availability window will begin. But you guys will have, it'll be timed. So unlike our quizzes, this will be timed for, you'll have 1 hour plus 15 minutes to take the exam. 15 minutes is to take a picture and upload it. So make sure that you, if you're doing that, make sure you start it no later than like 10:30, 10:45 on Friday morning. Okay, so give yourself that time because it won't let you upload it once you pass that window. Okay. Right. Okay. Okay. So I am going to keep working through I'm on the classwork for chapter 1.7. I'm going to keep working through classwork problems for 1.7. You guys, this question here, which is the part 1 of 1.7. This is question 3. This is more complicated than you would see. I'll just write that down. More complicated, complex than you would see on like a test or something like that. But I have it here, so I'll put it down. Put down our solutions for it, and then you can take a look. So let me work through the classwork for 1.7. I've got part 2 to start. Once I'm done with this problem here, and then I'll open up after I finish the classwork. I'll open up questions, like if you guys want to ask about homework or classwork or the review problems. Okay. So I'm going to start working on this one here. You guys are welcome to work on whatever you want, and then after I finish these classwork pages, then we'll start answering questions. Okay. All right. were told to have two methods, so here's another method here for question 1. Like I said, this is way more complicated than you would see. Lines in 3 dimensions are they're more complicated than if we had a line in 2 dimensions, because line in 2 dimensions I could find the normal, and then I would use that normal to help me find the closest distance. So this was a line in 3 dimensions, so it required methodology that we haven't necessarily discussed, but just so you'll have it. I'm gonna start on part 2. basically did this one with two different methods. I could have taken this point here and then added that distance to it so that I would have that value. Right, I'm going to add this point plus my projection. Right, that's another way of saying I'm going to add this length to that particular spot right there to get this point right here. Personally, I like the second method. I'll write this down as method 2. Method 1. They're both equally valid. I personally like the second method better, but it's up to you. Didn't actually take the magnitude, the distance between the point and the point of intersection. If I wanted to get the closest distance, I'd have to take that magnitude of that difference, but I didn't do that. I was just looking for the closest point. Definitely the intersection of the line and the plane.
Okay, so I'm done working on the classwork pages. You guys are free to ask me questions about classwork for 1.7 or homeworks or what have you. Remember, the homeworks that are due are homeworks that go from 1.5 to 1.7. So it's basically the rest of the chapter you're going to pass in. Okay, don't forget, I'll take the classwork for I think 1.5, 1.6 today. It's kind of a loose boundary. If you don't have it, that's fine. Give it to me by the exam period. I just kind of want to make sure that you don't have so many things to do on Thursday. Homework's due on Thursday at midnight. The problem set, number 1, is due on Thursday at midnight. And then you have your exam on Thursday too. Can you go over homework 22B and 28? Sure, let me get out my homework. Leave that there while I'm getting my homework set up. Just a sec to get my homeworks out. 21, 22. Okay, I'm gonna move this. The homework. This is homework chapter 1. Question 22B. So question 22 says, find the intersection of a line. So our line is L of t, which is 2t minus 2t plus 1 and t minus 1. So we're talking about a line in 3 dimensions. And then part B says we have plane M, which is perpendicular to our line L of t, and it goes through the origin. Okay, our origin is 0, 0, 0. All right, and so what we want is to find the intersection of the line and the plane. So our plane M, so first off, my vector on the line. So I'm going to extract the coefficients of my t. It's going to give me the vector that's on the line. So that's 2 minus 2, 1. Right, that's my vector that's on the line. So basically we're talking about, let's draw this picture. So I've got my plane M. Okay, so this line, and this is our
L of t. And the plane M goes through our origin 0, 0, 0. Okay, so this is L of t. That's L of t, basically the vector that's on the line is the normal to our plane. So essentially, so then, yeah. So remember our generic equation for a plane, right? So let's say I had my normal vector had components A, B, C, right? X, Y, and Z, A, B, C. And then I had a point on the plane, which we'll call X naught, Y naught, and Z naught. So my generic equation for a plane is going to be A times X minus X naught plus B, Y minus Y naught plus Z, Z minus Z naught equals 0. So now they said they want the plane to go through the origin. So this is our X naught, Y naught, Z naught. That's our point on the plane. And this, if our line is perpendicular to our plane, then the vector that's on the line is the normal. So this is our normal to the plane. So I'm going to take these components out. So this is going to be 2 times X minus 0 plus a minus 2 times Y minus 0 plus 1 times Z minus 0 equals 0. So I'm just going to clean that up. So this is going to be 2X minus 2Y plus Z equals 0. Okay. I think they wanted to find the intersection. So they wanted us to find the intersection of the line and the plane. So where does L of t, where does L of t intersect M? So we basically found the equation for our M, our plane. And now I have to take my L of t, plug it into here, solve for t, and then find the coordinate where that happens. Okay, so from L of t, I'm going to say x equals 2t, y equals minus 2t plus 1, z equals t minus 1. And I'm going to plug that into the plane, right? So this is going to be 2 times, wherever I see an x, I plug that in, minus 2 times minus 2t plus 1 plus t minus 1 equals 0. And I multiply through and solve for t. So 4t plus 4t, so minus minus, minus 2 plus t minus 1 equals 0. And then 4t, 8t, 9t, 9t minus 3 equals 0. Equals 1/3. We knew it was going to intersect, we just didn't know where. So then I take this t and I plug it back into here to find the point. This is equal to 2 times 1/3. Y is equal to minus 2 times 1/3 plus 1. Z, sorry, you can't see that. Z equals 1/3 minus 1. And I'm going to get this point here. So this is 2/3. It's going to be 1/3. This is, sorry, that's a third. And this is going to be minus 2/3. So our point of intersection is equal to 2/3. Oops, thank you. 1/3. Sorry about that. 1/3. There. And question 28. All right, so all right, so this one, 28, says we have 2 unit circles. So a unit circle means the radius is equal to 1. Okay, so we've got 2 unit circles, and they have centers. Center 1 equals 1 minus 1. Center 2 equals 2 minus 2. And do they overlap? Give me just a sec. I'm going to plot these out and then take a look, see what they look like. Maybe, looking for my. Okay. I'm going to plot these out so I can see. I'm just going to visualize, and then we'll go through the algebra. So, 3, 4, 5, 1, 2, 3. Okay, so my center is 1 minus 1, and my unit circle says I'm going 1 in each cardinal direction. So I'm going to draw a rough circle like that. My center is 2 minus 2. There's my other center. I'm going to go 1 point in each cardinal direction. Now I can see that they're going to overlap. Yes, but how? Let's actually prove it. So do the circles overlap? So I'm going to look at the distance between the two centers, right? And so let's do this. So I'm going to go 1 minus 2. So this is x minus x squared plus minus 1 minus a minus 2. Oops, sorry, there's 2 in there squared. This is our distance formula. So 1 minus 2, so that's a minus 1 squared is 1. Plus minus 1 plus 2 is 1 squared equal to radical 2. So radical 2 is like, 1 point something, right? And so if I take a look at the radii, so my radius here, so this radius here is equal to 1, and then this radius here is equal to 1, right? So if you think about it, I've got this circle here, it has a radius equal to 1. And then I have another circle here, and then this radius is equal to 1. So if I look at, if the circles don't overlap, they come really close, but they don't overlap. Let's say that they're touching. How about touching? Radius equals 1, radius equals 1. So the sum is equal to 2, right? So I'm looking at 2 radii. So if the sum of the 2 radii, right, the distance between the two centers is equal to radical 2, but that's less than sum of the 2 radii, therefore the circles overlap. It's easy to see in the graph, right? But we have to show it. So you can kind of think about it like, let's draw this. So I've got a radius here from here to here. That's radius equal to 1. And then I have another radius from here to here. I'm going to draw them off center so we can see them. And that radius is equal to 1. And so if I sum up, right, so here's radius equal to 1. Here's radius equal to 1. Okay. So if I sum up those 2 radii, right, the 2, 1 plus 1 is equal to 2. So the distance between them is going to equal to 2. But if the distance between my 2 centers, right, is less than the sum of the 2 radii, then those circles are going to be overlapping each other. Does that help? Get up there. I just want to take a look. Can you go over the problem set question number 2? Yeah, give me just a sec. Let me get my notes. I think left my problem set in my notebook. Give me just a second to get it. All right. Problem set. And this is question number 2. The pyramid below has a 2 by 2 square base with a height of 2. Okay, yes, it's an interesting one. So let's do this. I've got a square. So a 2 by 2 square base. So this is 2 and this is 2. And then I have how can I do this? Let's draw it like this. Like that. I'm not drawing this very well. And a height of 2. So the height is going to be like, I really over exaggerated this. The height, it's like really just straight down. Let's see if I can draw that better. This is our height. This is really standing straight upright. It's not leaning to the side. It should be standing straight upright. But our height is equal to 2. And let gamma be the angle between a base side and a slanting side. So we're looking at a base side and a slanting side. So we're looking at like this. That's going to be our gamma. Okay. Use the dot product to find the cosine. Okay. So what I'm going to do is I'm going to establish a set of an origin here. So I'm going to draw this out. Like this is my axis point. And it's a square, so I can do that. Like if this wasn't a square, then if it wasn't a square base, then it would be like off-centered from our axes. So this is X, Y, and Z axis, which means, I mean, I could set this anywhere, but by setting this here, then basically what I'm going to do is I'm going to establish this. I can call that a vector because this is a height of 2. So I've gone straight up. So I've gone basically, looks like I drew it differently. Let me get I had this notes up better in a different way. All right, I can't find my notes on that. All right, so basically what I'm going to do is I'm going to create this as a vector and then these as vectors here too. So essentially I've gone in this direction here. This vector is going to be, because it has a length of, I've gone out 2 units, then this vector here is I've gone 0 in the X direction, 2 in the Y, and 0 in the Z, okay? And then my height, the way that the height works is, right, the height cuts down and it hits right in half. So this is 1, this is 1. It's just like the nature of, if I draw this as a square, and you can imagine my height's coming off the table here as the pyramid, sits down. So my height comes straight off. So if this is a unit, this is 2 units, then this has only gone 1 and 1. So I've basically gone out 1 in the negative X direction, right? So this is going to be, so I've gone 1 in the negative X direction. So this is -1. I've gone positive 1 in the Y direction, and I've gone 2 in the Z direction. Okay, so now I have 2 vectors, right? So let's call this V, and I'll call this W, just for lack of, whatever. So you can think about it like this. I've got a V. Here's this here, so I have room to work. So I have V is equal to -1. Oops. I think I cut off the page. -1, 1, and this was a 2. 1, 1, 2. And then I have another vector here, which was W, which is equal to 0, 2, 0. Okay, so then gamma is the angle between those two. So now we know what to do, where if we think about our definition of the dot product, right? So if I say V dot W is equal to the magnitude of V times the magnitude of W times the cosine of the angle between them. So I'm going to exploit this, right? So if I divide this by the magnitudes, I'm going to get that equal to the cosine. So let's write it down. So I'm going to say cosine of the angle between them is their dot product divided by their magnitudes. And they just said to find the cosine of gamma. So they didn't even ask us for what gamma was, but just what the cosine was. So I'm going to take the dot product, that's going to be minus 1, 1, 2, dot, 0, 2, 0, all over. I had to figure out the magnitude. So the magnitude of W is equal to 2 squared, that's just equal to 2. So 0 squared plus 2 squared plus 0 squared, square rooted, equals 2. Magnitude of V is equal to, I'm going to take minus 1 squared plus 1 squared plus 2 squared. Oops, that's a squared. This is 1 plus 1 plus 4. So this is radical 6. So I'm going to go 2 times radical 6, right? That's my magnitude here. And that's equal to the cosine of that. So this is 2 all over 2 radical 6 equal to 1 over radical 6. They just asked me for the cosine. Didn't even ask me for what the actual angle measure was. If I wanted the actual angle measure, I would take the inverse cosine, but they didn't ask for that. The trick on here was establishing an origin spot. Because it's a square base, I can just pick any, and I could have picked this as the center. The answer would be the same, but your individual vectors would be different. I found it easier because I'm going to do terminal minus initial. So my initial point is at the origin. So my vector then is just my terminal point minus my initial point, which is 0, 0, 0. And then my terminal point, right, minus my initial point gives me the vector 0, 2, 0. So I had to know, the other trick was to know my geometry, which was that the height drops down right to the middle. So let's draw this out again. I'll draw it here. So this is my height my height comes down here and it hits exactly in the middle of my square. That's like the nature of it. So if you're sitting in the middle of the square, I've only gone 1 unit in either direction. So that helps me come up with this vector here, which is off the page, right? Because I've only gone over -1 in the x direction, because this is our positive x. So then this is our negative x direction. So -1 in the x, +1 in the y. This is our negative y direction, our negative z. And then up +2, because we were told that the height was equal to 2. So that's how you come up with the vectors. And then from the vectors, I can do the dot product. And then the dot product's going to give me the angle between those two. Okay. Okay, guys? Why don't you guys come to Wednesday's class prepared to ask questions. I'm just it's gonna be like office hours on Wednesday. I mean, it's up to you, but come prepared to ask questions. You can ask questions on the problem set, on the homeworks, on the various classworks that we've done, or on the sample problems for the midterm. I think those contain answers too. So let me just check. Those contain answers too. So you can come and take a look at those and then ask me questions like, what do those things mean? And then, so Wednesday's class is for you to ask questions on all that. Okay. All right, guys. Have a great day. I'll see you on Wednesday.